Hey Quinta, I hope everybody's doing okay. So today, this week is going to be a little bit different than the last weeks that we've been doing distance learning. Today, I'd like you to please take careful notes of the lesson. This lesson will be about a half an hour long, and I just want to see that you're really engaged and listening and paying close attention. So please, just like, do you remember when I had you for last week? You wrote out this chart and then you uploaded it to Google Form. Uh, please do the same for your notes. Take a picture of it and upload the image. Please try and keep the image small. I don't need a high quality resolution picture of it. I just want to look at it. Please don't email me these images, because when I email, I have to open it and then download. And it's just, when I do it on Google Forms, I can open a folder and I just click, 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 click through all 45 pictures, and it's much, much faster for me. So please do not email me your notes. Send them through the Google form. Also, I'm going to have you answer a few questions on the Google form, and then I'd like you to come up with at least one question that you've had in the last month. And Friday will be a live class, and I'll answer all the relevant questions on Friday. So please put up your notes and any questions you have of the material we've been doing. You guys have been doing great. I really feel good about the progress I've seen. So anyway, please email me if you have any questions. Get out your notes in your math notebook. I hope you have it at home, and let's get started. Thanks. Okay, so just as a quick review, last week you sent me your chart of 30, 60, and 45 degree trig ratios. Hopefully these make sense. In a normal school year, I would have my students memorize these 9 values. But if you understand where they come from and you can draw the triangles, you can always figure these out. You can draw a 45, 45, 90 triangle. Know the ratio is 1, 1, and then square root 2 times whatever the side lengths are. And so sine of 45 degrees is opposite over hypotenuse, 1 over square root 2, and then we rationalize the denominator to get square root 2 over 2. So I hope this makes sense, and I hope at the very least, they're very familiar to you. If not, I hope you have them memorized. That would be even better. It will come in handy. All right, so grab a calculator, maybe pause the video and find your calculator. Convert it to degrees. The other thing we'll get to by the end of the year, radians, but not yet. So turn your calculator to degrees and then type in sine of 30. In your head, you should already know what that is, but you should get this. Sorry, it's kind of glary. Sine of 30 degrees is 0.5 or 1/2. Perfect. So the computer or the calculator or whatever you used agrees with the manual labor you've been doing. So now the weird thing is, though, what if I did the sine of 150 degrees? Can you see that? It's the same. But wait a minute, sine of 150 degrees is really big, and it's not even it can't be a right triangle because 150 plus 90 is too much. It can be a triangle. You can have 150 and then the other 2 angles add to 30, but how does that work? Like, why does my calculator say that it's 0.5, same as sine of 30? Well, here's something crazy. I type in the sine of 210 degrees negative. How do you get a trig ratio that's negative? That means one of your side lengths is negative, and this is all very mysterious. What's going on? And then you can also do sine of 330, which is now really getting ridiculous, and it's negative 1/2. So what's going on? Well, that's what I'd like to get to, and I think it might take me 3 lessons until I can fully explain it. So we have to do it in baby steps. The first step is to take these triangles that you've been seeing that are just floating around in empty space with just nothing around them, just white paper. And we're going to fix them on the coordinate grid. So let's get ready, take out your notes, and let's get started. Okay, so in your notes, please draw your X and Y axes and clearly label your origin 0, 0. And I'm going to review a few vocabulary words. If you don't know them in English, please write them down. So the origin, this horizontal axis is your x-axis, and the vertical axis is your y-axis. So do you remember, we did this last year, we divide the Cartesian grid into quadrants, 4 quadrants. Quadrant 1, x and y are positive. Quadrant 2, so x and y are both positive. In quadrant 1, we have positive numbers here. Oops, I just erased my x-axis. And then positive numbers going up. And then in quadrant 1, and in quadrant 2, x is negative and y is positive. So if you have a point in quadrant 2, the x must be negative and the y is positive. In quadrant 3, they're both negative. And in quadrant 4, the x is positive and y is negative. So if you don't remember that, please write that down. And okay, so now starting with your XY coordinate system, from 0, 0, we are going to draw a ray. Now remember, a ray is sort of like a line, but instead of going infinitely in opposite directions, it just goes infinitely out in one direction. It has an end point, if you remember that. And for our purposes, for what we're going to work on solving this mystery of why sine of 330 degrees is negative 1/2, we always have the ray at the origin. This is really important. So the ray starts at the origin, and then it just shoots out like this. And it can be down here, it can be in quadrant 3, it can be in quadrant 2 or quadrant 1, but it always, it's like the hands of a clock. It's always right in the center of our grid. Okay. Okay, so for the first example, I'm just going to put our ray going through quadrant 1. Now there's some more vocabulary I need to teach you. So this the positive part of the x-axis. So this part's the negative numbers, just for the positives. So we're going to look at the positive x-axis, that thing I just did in red, and that's going to be called the initial side of our angle, the initial side. So please write that down into your notes. I'll be looking for that when I look through your notes. The initial side of the angle. And this top part of the ray, this ray is the terminal side. So the initial side is the positive x-axis, and the terminal side of my angle is the ray that I've drawn. The positive x-axis does not move. The terminal side, or the ray, moves. And then if you look in here, this part is the angle that I'm going to be looking at. So in here, that's the angle. So the angle always backs up into the origin. It's always squeezed into the origin right here. And it makes sense, I think. You know, you could draw a line from here down. Oh, it's so hard to do this backwards. You could draw a line from here down, but this is the angle without adding any other lines. That's what you see. So that positive x-axis is the initial side of my angle, and then the ray that I drew in is the terminal side of my angle. So here I've drawn an example of what it would look like. We start with the initial side of the angle that always stays fixed, and then we lift up, we go up, and we use the ray as the terminal side, and that space in there is our angle, and this is approximately 40 degrees, but you can draw anything. All right, so instead of me erasing and having to stop the video and do this over and over again, I'm going to switch so you can see the next thing I'll film will be my computer. So here I have a really nice app that I just made this in GeoGebra. So here is my initial side of my angle. There's my angle, and then there's the ray, which is the terminal side. So I can keep this in quadrant 1, and in quadrant 1 I have 0 degrees, and then I go all the way up, and I hope you can see what's happening. We can go all the way till 90. I overshot it a little bit there. There's 90 degrees right angle. If I have an angle more than 90 degrees, now here I'm going to go into quadrant 2. And I hope you can see that that's going to be angles between 90 and 180 degrees. Overshot it a little bit. Pop right there. And then that's quadrant 2 from 90 to 180. Quadrant 3 is 180. Do you know what it is? What's halfway between 180 and 360? If you were thinking 270, very good. And then quadrant 4 is the angles between 270 and 360. So that last screenshot was an app that I just used GeoGebra to make. But this, somebody else made. Here's the website if you'd like to play around with it. Ignore this radians for now. That's just another way to measure an angle. Focus on what we're familiar with, the degrees. I'll teach you this, but not for a while. And so here's a slider, and I'm going to take this. This is my initial side of my ray, and then this little thing here is the terminal side. And let's try and get to 270. There we go. So now we start here always on the positive x-axis, and then we go around. This blue line is indicating that it's a positive angle. And a way to remember is that it goes up into quadrant 1 first, and that's all positives. X is positive as Y is positive. It's kind of strange that it's counterclockwise. It goes the opposite way of a clock. And then we come around, we get to 360 like I did. Oops, we get to 360. I can't quite hit it like we did on the previous screenshot. But now the nice thing about this is I can show you that you can keep rotating around the origin. So this angle, if I go... So here I am. This was the first time that the terminal side of my angle, hit the y-axis. It was 90 degrees. That was right here. And then I came around 90 plus 360 was 450. 450 plus another 360 degrees. And you have 8, 10. So these are all, they're called co-terminal angles, and they're really the same position. You still have this initial side of your ray on the x-axis and your terminal side on the y-axis. The only way you can tell them apart is either if you write the number out or if you draw in loops to measure how many times you've gone around. And then you can keep doing this forever. This app only the slider stops at 1080, wrapping around 360, 720, 1080. And now you can go, I can make that a little bit bigger. You can go in a negative direction. So here you're dropping down to where the y is negative 70 degrees. Ignore this for now. So I drop down, and this is almost almost at 90. You see, when I draw it, I start the red line. I would start the red line here and draw it to here, but this is fine. They're doing that so you can really see the spiral. And then now I'm at negative 270 degrees. That's this, it's a co-angle that's coterminal with 90 degrees. Coterminal meaning that they terminate or they end at the same spot. So if you had that blue line, it would go this way. The red, negative 270 this way. Now I'm going to make my terminal side a little bit smaller so I can keep going around. And then negative 1080. The same beginning and end as positive 1080, but these little swirls tell you it's a negative angle.